Hi all, welcome to the lecture series on solving previous year questions of GATE ECE, and we were solving the questions related to analog circuits. So today we will be solving the questions related to diodes. So this is the first question. This is from GATE 2025. The question is, all the diodes in the circuit given below are ideal. Which of the following plots is or are correct with VI in volts is swept from minus M to M. So the input VI is swept from minus M voltage to capital M. Okay, so as you can see here, this is a bridge circuit. Okay, and we'll see how it works. So suppose VI is greater than 0 volt or in the range 0 to M. Okay, so the voltage drop will be like here plus, here minus. So what happens, the diode, say this is D1, this is D2, D3 and D4. The D1 and D3 will be on, so this is plus, this is minus, so D1 and D3 is on, and D4 and D5 D4 and D2 will be off, so this is off, right? So because of this, there will be a flow of current like this through diode D1, through the resistance R, through D3, and will flow like this. So this will be the current I1. Okay, and so we can draw the transfer cara. So if this is Vi and this is V0, so from 0 to M, what will be the voltage V0? So since this is the flow of current, and since D1 and D3 all diodes are ideal, we can also draw the circuit like this. Right, so this is Vi. Okay, the other path is off. So this node is this node, and this node is corresponding to this node. So what is the voltage V0? V0 will be equal to Vi itself, right? So whatever is the sweep change in Vi, that will be linearly changing in V0 also, like this, right? Now what happens when Vi is less than 0? When Vi is less than 0, or Vi is in the range of minus M to 0, okay, so the voltage polarity will be like this, minus plus. Okay, so here this is plus and this is minus. So what happens, the diode, say this is D1, D2, D3, D4. D1 and D3 will be off, and D2 and D4 will be on, right? So there will be flow of current like this, right? So that will be the current. So if you see here, the current I1 is reversed, right? I1 is in this direction actually. Okay, it's reversed, and we will also draw the circuit here. So it will be like this. So diodes are ideal, so diode circuit will be like this. This is off, these two diodes are off, so this is Vi, and the polarity is here plus, here minus. So this plus is this at this node, and this minus is at this node, and we know this is the voltage V0. So if you see here, V0 is again equal to Vi itself, and the polarity is same as previous, right? These two polarity are same. So as Vi changes, the voltage of V0 is still positive. So what happens, it will be like this, right? So the answer is like A. Answer is A. Now we can, it is like it is said in the question, any other option is also correct, right? So if you see here, option B is wrong. Okay, and we'll see what happens here in C and D. So here C is like Vi versus Ii. Okay, so this is 1 and this is 2. Okay, so in first case, case 1, I1 is like, I1 is flowing in this direction. I1 is flowing in this direction. Okay, so I1 is positive, and what is the current I1? I1 is equal to, okay, I1 is equal to Vi by the resistance R. Okay, and here maximum value will be equal to M by R will be the maximum. Okay, this will be the maximum current. And similarly for the case 2, what will be the I1? So if you see here, the current will flow in this direction. From here, in this direction the current flow. So while I1, it is denoted as in this direction. So here the current is opposite. So the current I1 will be equal to minus Vi by R, or minus M by R will be the maximum. Okay, so if I draw Vi versus II, okay, so as Vi increases, the current also increases. So when Vi reaches M, the current II will be equal to M by R, and when the Vi decreases, the next case, right, when Vi reaches minus M, the current is also minus M by R, right. So answer is actually D. So we can have either the option A or D. So answer both A and D is correct, while B and C is wrong. And see the next question 2. Okay, again it is from GATE 2025. The question is, the diode in the circuit shown below is ideal. So this is the diode. The input voltage is given by Vi equal to 10 sine 100 pi t, where t is in second. Okay, so given Vi is a sinusoidal signal, right, and the peak is 10 and minus 10, right. So what is the frequency here from the signal? Vi is equal to 10 sine 100 pi t. Okay, so this is like 2 pi f t. So here from the equation, what is f? F is equal to 2 into 50 is 100, right? So f is equal to 50 hertz, right? So what is the time period? So if this is the total time period of this input signal, time period I will call t as equal to 1 by f, right? So that is 1 by 50, that is equal to 20 millisecond, right? So that is the time period. Now the question is like the time duration for which the diode is followed by. So if you see here, it's actually a clipper circuit and it's a biased clipper. Here it is minus and plus, right? So when Vi is 0, this diode is actually on. Okay, so it is when Vi equal to 0, diode is on. Okay, and if you see, since it is already on, for Vi greater than 0, diode is on, right. So during this case, when Vi is positive, the diode is on. When does diode becomes off? So when diode becomes off, when this voltage minus this voltage is 0 or less than 0, right. So when Vi minus 5 is less than 0, right, or Vi is less than minus 5 volt, okay, diode is off, right. So when does this happens? So when does Vi becomes minus 5? This happens when sine 100 pi t is equal to 1 by 2, right. So when does this happen? This happens when the angle, right, 100 pi t is equal to, so there is two cases, okay, when this it becomes minus 5. This is when at this point and this point, I will say this is t1 and I will call this time period as t2. Angle, what is this? This happens when t equal to t1, that is 100 pi t1, and this happens when this is equal to uh, pi plus pi by 6. This is one case, that is like can happen at 180 plus 30 degree or 360 minus 30 degree. These are the two cases when this becomes 1 minus 1 by 2. So that is pi plus, in radians it is like plus pi plus pi by 6. Pi by 6 is the 30 degree, right? So from here if we calculate, T1 will be equal to 7 by 6 into 100. 7 by 6 into 100. Okay, and so this will be T1. And the case 2 is like when T is equal to T2. So this happens when 100 by T2 is equal to this case, that is 2 pi minus pi by 6. This is the other case. Okay, so here T2 will be equal to, if you reduce, T2 is equal to 11 by 6 into 100, right? So here if you carefully see, from T1 to T2 the diode is off, and the remaining time, that is this time, diode is on, and during this time is also diode is on. So on time of diode is like total time T minus T1, the total the time when diode was off, right? T2 minus T1. Okay, so if I substitute, T is actually 20 milli minus T2 is 11 by 6 into 100 minus T1 is 7 by 6 into 100. So if you calculate this, you will get near to 13.3 millisecond. So the answer is 13.3 milli. Fine. Yeah. Now the next question is, an ideal PN junction germanium diode has a reverse saturation current of 10 microampere at 100K. So the reverse saturation current IS is actually 10 microampere. Okay. And this is at the temperature T equal to 300 Kelvin. Okay, the voltage to be applied across the junction to get the forward bias current of 100 milliampere at 300 Kelvin is, okay. So question is, at what voltage the diode will have 100 milliampere. So we know the diode current, okay, ID is given as IS into e power the voltage across the diode Vd by eta Vt minus 1. Okay, so here IS is given. Okay, let eta be equal to 1 because it's not given here. Vt is actually the thermal voltage, that is K into T by Q. Okay, where K is the Boltzmann's constant, that is 1.38 into 10 power minus 23. T is the temperature in Kelvin, so here it is 300 Kelvin by Q. Q is actually E, given this is Q. So that is 1.6 into 10 power minus 19. Okay, so that is a charge. So if we calculate this, I'll get some 25.83 millivolt. Now if I substitute here in this equation, so ID given here is actually 100 milliampere, right? So if I substitute here this equation, in this equation, so ID is 100 milli, IS is 10 micro, that into e power Vd is the voltage that I need to find, eta is set as 1, this is 25.83 milli minus 1. Okay, so from here what will the Vd, what will be Vd here, it will be equal to 25.83 milli into natural logarithm of 100 milli by 10 micro plus 1. Okay, so if we substitute this and if you reduce, we will get it as 237.9 millivolt. Okay, or here it is given like in volts, right? So it is like 0.237 9 volts. It's approximately equal to 0.24 volts. So you can write any value from 0.23 to 0.24, right? So it's like 0.237 volts, right? Yeah, thank you.